In this video, we're going to be talking about how we start to quantify not just what substance is dissolved in a solution, but also how much of that substance is dissolved in a solution. And we do this with what's known as the concentration. So in the most general sense, concentration is the relative amount of something in a particular volume of space. A particular area of space. Keep it super general here. So concentration is something that we use to measure the amount of solute dissolved in a solution. But the idea of concentration can really be applied to anything. Population density is a concentration. How many people per square mile? How many somethings is your people in an area of space is a square mile? Pressure is essentially a concentration. Tire pressure is usually pounds per square inch. How many pounds of pressure on every square inch of space on the inside of a tire. So there are lots of different applications for the idea of concentration. For us right now, we're going to be talking about the amount of solute dissolved in a particular amount of solution. And we can talk about the concentration either qualitatively or quantitatively. We'll mostly focus on the quantitative side of things, adding numbers, but I do want to just kind of throw out the qualitative descriptors that you'll be hearing. So qualitatively, we can say that a solution is either concentrated or dilute. So something is considered concentrated if there is a large amount of solute dissolved and something is considered dilute if there is a small amount of solvent dissolved. Now, I know these types of definitions can be kind of frustratingly vague. What is a large amount? What is a small amount? And the thing is, it's really context dependent. So for solutions, a decent turning point is 1 mole of a substance in every liter, but that isn't always going to be applicable. So generally, for most things, it's relatively dilute. If there's less than 1 mole in a liter, it's relatively concentrated if there's more than 1 mole in a liter. But again, it's a really fuzzy barrier. So these are mostly words that you'll hear me use in certain situations to say like, oh, you're working with a pretty concentrated acid today, be careful. That means that there is a lot of acid in that solution. Or, you know, sometimes a student will like get acid on their skin in the lab, just to continue with that example, and they're like, oh my gosh, what do I do? Am I gonna like lose my hand? I'm like, no, it's a dilute acid. There's not a lot of acid in there, so you're fine. Wash it off and go about your day. So you'll hear these words thrown around, but don't stress too much about what the exact definition is, because there just isn't one. If we want to quantify concentration, if we want to actually attach numbers to it, there are a lot of different ways that we can do that. There are a ton of different units associated with concentration, but there is one in particular that chemists tend to use the most, and that is known as molarity. So the molarity of a solution is symbolized by a capital letter M, and molarity is the moles of solute dissolved per liter of solution. Note that it is per liter of solution in total, not just the solvent. So when your solute dissolves, you can't see it anymore, but it does still take up space. So in most situations, to make a liter of solution, you need less than a liter of solvent. So if you're making a liter of aqueous sodium chloride, you mix your water and your salt together, but you probably don't need a whole liter of water, a little bit less. And we'll talk about how you actually make a solution in the lab. How do you know how much water you need? We'll talk about it. So you'll often see this expressed mathematically as molarity is moles of solute per liter of solution. And that's an abbreviation for solution on the bottom there. Or sometimes this will just be simplified 2 moles per liter. So this is our definition for molarity. And you're going to be using molarity for the rest of the semester, so get really comfy with it now because it is going to come into play in some way, shape, or form in literally every unit from here on out. So I just want to do one quick example of how we calculate a molarity. So we're going to calculate the molarity of a solution prepared by dissolving 45 grams of calcium chloride in enough water to make 500 milliliters of solution. So this is our definition of molarity. So in order to calculate a molarity, we need to know moles of solute, we need to know liters of solution. So those are the two things we need to figure out first in order to be able to finish this question. So we're going to need to calculate moles of solute. And in this example, our solute was calcium chloride. That's the thing that we're dissolving. Then we are going to need to calculate, if it's not given, liters of solution, which in this case we're not quite given. And then last but not least, we will be able to put those two things together to calculate the molarity. So to calculate the moles of calcium chloride, we can look at the information that we're given. So to do this, we're going to need the mass of calcium chloride, and we'll need to convert that mass into a number of moles. And we do that using the molar mass of this substance. So we can look to the periodic table for our molar mass. If we add up the masses of all of our atoms, we add 1 calcium plus 2 chlorine. We will find a molar mass for calcium chloride of 110.984 grams per mole. So that is our conversion factor between grams and moles for calcium chloride, and we can use that to do this conversion. So if we have 45.0 grams of calcium chloride, we want to use that conversion factor, that molar mass, to convert into moles. So this number of grams of calcium chloride is equal to 1 mole. Since we're currently in grams, we want that unit to cancel out, so we'll put that mass on the bottom. 110.984 grams of calcium chloride is equal to 1 mole, which is the answer, or the unit rather, we're looking to get into. So that new unit will go on the top. So grams of calcium chloride cancels grams of calcium chloride. And our new unit that we end up in is moles, which is what we're looking for. So we find 0.4044 moles of calcium chloride, and then we're going to need that number again later when we go to ultimately calculate our molarity. So up next, we're going to need to calculate the liters of solution. We're told in the problem that we're making 500 milliliters of solution. So for this part, we just need to do quick metric conversion. We have 500 milliliters. There are 1,000 milliliters in a liter. So 1,000 milliliters goes on the bottom, 1 liter goes on the top. So 500 milliliters is 0.500 liters. Then last but not least, we can take these two results we just got here, here, and here, and combine those in our final answer. So our definition of molarity was moles divided by liters. So all we have to do is plug in our number of moles into the top, our number of liters into the bottom. So the molarity of this solution is going to be 0.4055 moles per 0.500 liters, which comes out to 0.811 molar. So our final answer is that there are 0.0811 moles in every liter of this solution.